general relativity, step by step. We've established this quite nice identity here that g of r equals k, some constant k, over f of r, where g of r and f of r are as yet unknown functions, which appear in the metric tensor in the vicinity of the black hole. So what I'm going to do is try and pin down what that function is, and in particular what this constant is here. So I'll do that now. Set up my Maxima thing, because I'm not going to be doing all this algebra. Right, let's go. Load. Actually, I've got some of it here. I can grab that. Copy and paste. There we go. And I'll set myself the tensor to be a matrix. Oops, caps lock. Right, it was minus f of r 0, 0, 0, comma 0, some constant k. Now this is why you tell it that t and r and theta and phi are the coordinates, because it will interpret k as a variable whose value we don't know. It's going to leave it symbolic. Over f of r, that's the right sign, isn't it? 0, 0, 0, 0, r squared times sine theta squared, close bracket. I think we need a semicolon at the end. There we go. Yes, that's worked out. Okay, so if I type C metric, it'll do all the calculations behind the scenes for us. Just give it a minute to process. Do I need to? Oh yeah, it says it's done. And then if I type Ricci true, it gives me the Ricci tensor. In a much easier to understand form. We've got this 2k and kr, we've got all sorts of complicated stuff here. Now from this we should be able to work out the constant k. We should be able to work it out. So we've got a whole bunch of information here. Let's just have a think about this. Okay, so we've got a whole bunch of equations, and I've just been thinking about them. We'll have a look at the Ricci 2, which we know to be equal to 0. And in symbolic form, that tells me that, well, I'll write it out. Let me see if I can, no, I won't be able to have both at the same time. But what we've got is f dash dash over 2f minus, or it's minus that, isn't it? Well, let's ignore the signs. F dash dash over 2f plus f dash over rf equals 0. So let's just have a look at that. Let me push that over there, and oh no, I need to, okay. Right. Okay, so that tells me that, let me have a look at it again. F dash dash over 2f, f dash dash over 2f, plus, because we're ignoring the signs, f dash over rf. F dash over rf equals 0. Okay, so that tells me that f dash dash equals minus f dash over r. What's happened to my 2? My 2 goes there. 2, 2 there. If I define h to be equal to f dash, what happens? That says that h dash equals minus 2 over r times h. So h dash over h equals minus 2 over r. So d by dr of log h equals minus 2r minus 1. Log h equals the integral of minus 2r to minus 1 dr. Hang on. Equals minus 2 log r. I'm writing that very neatly. I'll do it better. Minus 2 log r plus an integration constant. So that tells me that h equals c r to minus 2. That's nice. So that tells me that f equals the integral of CR to the minus 2 dr. C is a constant of integration, which equals CR to the minus 1 plus another constant, call it capital K. So f of r, after all this, equals some constant of integration plus another constant of integration over r. Well, that's nice. That's nice, isn't it? And we know that g of r equals, I think I call it lowercase k, over f of r, which we established from the first and second elements of the Ricci tensor, which equals this k, which we still don't know, over capital K plus capital C over r, where k and c are as yet unknown constants. And we're going to have to use a mixture of mathematical and physical reasoning to pin these things down. But we can rewrite our metric tensor. Remember, we had f of r, minus, wasn't it? 0, 0, 0, 0, g of r, 0, 0, 0, 0, r squared, 0, 0, r, 0, r squared, sine squared theta. Now we can substitute, because we know a little bit at least about these functions here. Oops. So that is now equal to minus some constant. Oh no, it hasn't got a constant there, that's just a 1. That is just minus k plus c over r, 0, 0, 0, 0, k over k plus c over r, 0, 0, and these terms are unaffected. That's an r squared, 0, 0, 0, r squared, sine squared theta. Beautiful. So what I'm going to do is to put that lot back into the Maxima system in the next screencast and see if I can pin down what this lowercase k, the uppercase k, and the capital C altogether are. Stop there. Stop. It's getting together. It's coming together.